What's up next? Weather, something near and dear to all of our hearts. So what's ahead for the summer? I'm not going to take a shot at that. We have somebody far more qualified. Our next presenter is Mark Russo. Mark is the Chief Science Officer at Everstream Analytics. He leads the applied meteorology team to ensure weather forecasting accuracy, product timeliness, and customer-focused, impact-oriented communication for supply chains, business operations, and commodity hedging and trading. Mark is also an American Meteorological Society certified consulting meteorologist. So today, Mark is going to discuss the upcoming weather for this summer. And Mark, I believe they'll all hold you to it. So best of luck, brother. Let's have a round of applause for Mark as we introduce him here. Hey, Mark.
Thanks, Don.
Good luck.
Thanks. Thanks, Don. Thank you, Mike, and to all of ACES for the invitation here to speak today. And the pressure's on. When dealing in the world of prediction, whether that's predicting weather, whether that's predicting whether the Chicago Cubs or St. Louis Cardinals are going to win the World Series, or just predicting what market conditions are going to be. Yeah, that's a very, very tough job to do, but weather's always been my passion, something I wanted to do basically since I was a little kid. So to be in a career to predict the weather, obviously not perfect every time, but to be a big part of it here, the challenge is immense, but it is really exciting. And with the just a little background here with my company, Everstream Analytics. Actually, just as an FYI, for this ACES conference, I'm a rookie. This is first time being at this conference. Again, thank you for the invitation. You might know my colleague, John Davis. He's spoken at this conference numerous times over the past several decades. So actually, John and myself, we co-lead the applied meteorology team, and based in the Chicago area, although John moved to Barcelona, Spain, a few years ago. So he's in a much better place weather-wise compared to Chicago. So with some of the recent winters, his timing was very good. So what we do at Everstream, and basically we are the only company that is full end-to-end supply chain risk management. And weather is a big part of that, especially the prediction of, will there be weather disruptions that could cause issues for business operations or for supply chain networks. And so that's a big part of it, but we also have data science teams, risk intelligence teams that are monitoring situations and events around the world that could disrupt supply chains and supply chain networks. And so actually the company here is brand new. We just rebranded just a few months ago, and we service all different sectors. Energy is obviously a huge one, but we also deal with agriculture, food and beverage, transportation, manufacturing, so on and so forth. So our applications and then our advisory services then cover what we think is going on right now that could be disruptive, but then more importantly, a lot of the analytics that we produce to help aid in what's ahead, that we could get our customers out in front of upcoming events that could disrupt their operations. So with my talk here today, actually the bulk of my talk is going to be forward-looking. What's ahead for this summer, especially just focused here on the U.S. In terms of temperature, in terms of rainfall, and then what are some of the main drivers? Why are things happening as they are? And then ultimately, then for this hurricane season that pretty much we've just started right now, kind of June 1st is the traditional start, kind of our big picture thoughts there. So let's get right to it, and going to start off with what we think is our macro summer temperature forecast here. So months of June, July, and August, what you're looking at, this is a map of our general expectations, the risk areas for heat this summer, and then other areas that are least favored for heat. So the red shaded areas, as you see, those are where we're expecting warmer than normal temperatures during the months of June, July, and August. And then the blue shaded areas, more cooler than normal temperatures. And this is all based on what we define as normal. That is based on the last 10 years, which actually the last 10 years of data, we'll highlight this here in a minute, things have certainly been changing, and depending on what kind of base state that you look at and use data with, there are some big differences between using the last 10 years of data versus the past 20 or 30 years. So that's true with weather and climate data, but as we all know, with all kinds of data, whether that's natural gas data, power data, things are changing, and with that, obviously being adapting to those changes in data sets and trends in those data sets in recent decades. So big picture wise, we think that the highest risk for heat this summer is going to be more so across the western U.S. And then that kind of arcs, as you see, into the northern plains. And we think that's the pattern that's already beginning to evolve here in June. We think this is going to be the primary pattern as we go through the next several months. So for places such as California, already dealing with dryness due to long-term drought, portions of the Rockies too in very dry conditions. That's a big part of the heat expectations, which I'll talk about. But then we think overall that there's this more of a risk of actually this northern-based heat. So northern plains are like Montana and the Dakotas actually compared to Texas. And as you see here, in a place like Texas, especially given everything that's transpired in recent months, and then actually especially this significant increase in rainfall over the past several weeks, that's been a marked change in the pattern, helping to improve soil moisture, and this upper level pattern that's in place is favoring more heat, further up north. What we call these EMLs, or bubbles of heat. EML stands for elevated mixed layer. So that's more of the technical term. But with these EMLs, what they do is they develop over the elevated areas of the west. They heat up, and then if you get the right pattern, those are the heat waves that then move eastward. Sometimes those bubbles of heat take a northerly track. Other summers, they take more of a southerly track. We think this year is going to be a season that features more of a northerly track, so that, with the exception of California, but taking more of this track that takes it across the northern plains and then at times into the Midwest and Northeast. But all in all, more consistent heat out across the western U.S. And then again, southern U.S., obviously normally a hotter area, but reduced heat risks, or in general a cooler than average summer, or at least for the months of June, July, and August. And then when you put everything together here, just from a big picture, national population-weighted cooling degree day standpoint, we are expecting closer to normal, which, kind of going into a bit more detail there, this is a time series of June through August cooling degree days. And again, for I think most individuals here know what a cooling degree day is, but just for reference, it's basically a temperature metric based off of, well, for summer, it's based off of 65. So the higher the temperature is above 65, the higher the cooling degree days. And then those are aggregated by city, by state, ultimately by national values here. And so this time series goes all the way back to 1950. And we added our forecast to that. Our forecast specifically is 976, which as you see is close to the 10-year average of 977. Overall, that would be lower than a year ago. As you see, last year was one of the top 5 highest pop-weighted CDD summers going back to since 1950. And so this year, based on our research, we are expecting at least a bit more tempered, a tempered pattern overall for the lower 48. I do want to call out here, and you likely have already noticed this looking at the time series, is that there's some distinct trends. And the trend is in the upward direction. Again, this is just June through August, but if you compare the past 10 years of cooling degree data to the 10-year average and comparing that to the 30-year average, that's a difference of 6.5%. So when you're dealing with summer or longer term temperatures, that difference of 6.5% is very noteworthy. And even a normal summer now, which is what we're expecting, again, that's much different than what a normal summer was back 3, 4, and 5 decades ago. So compared to recent times, we're expecting a bit more subdued summer, cooling demand-wise, but compared to the past several decades, it's looking much more significant. Now, what about rainfall here upcoming? We are expecting, in general, a drier bias across much of the western half of the country, with the exception of the desert Southwest, well, Arizona and New Mexico. Some of the driest conditions, though, look to be in the interior Rockies and on into the northern plains. And ultimately here for the current drought, which I'll talk more details of that here in a minute, the drought conditions that are in place out west, we are not expecting any kind of major improvement here going forward. And really for that area, for there to be significant improvement, we now have to wait to the next what we call water season, which really doesn't kick in until next fall. There's the southwest monsoon, which provides rainfall, but your totals during like the months of July and August are typically much less compared to your kind of jet stream rains that can occur during the fall, winter, and spring. So the drought conditions out west are going to continue to be in place for an extended period of time. And then combined with some of the warmth that we're expecting, again, from a wildfire risk out west, that risk is again is elevated significantly. I don't think you can forecast, again, compared to last year and just the past couple of years, they were obviously really bad fire seasons. That risk is certainly heightened, but where do those wildfires start? Are they in relation to cities and infrastructure, and then ultimately damage? Then that's you can't predict those types of things, but obviously, the risk is again elevated for this season, kind of given these conditions. Now, outside of that zone, as you see, the Gulf Coast, East Coast, in general, kind of normal. A few pockets of what are the normal conditions, which again, that kind of goes hand in hand with the lack of any kind of rainfall, lack of any kind of heat or sustained heat across those areas. So. With the general kind of normal to wetter bias there, at least in terms of hydro availability, overall water conditions, things look to be in pretty good shape. Now, with the drought, across the western U.S. What this map is showing, and some of you may be familiar with this, actually a show of hands, who's familiar with the drought monitor? Okay, some of you are? Yeah, so this data is all publicly available. If you go to, and all of a sudden the website here escaped me. I think it's just drought.gov, or at least that's a link that can take you to the National Drought Center. They're based out of the Lincoln, Nebraska area. This is actually the map from a week ago. This data comes out every Thursday, so actually the new one came out here today. And as of last week, and I'm sure the new data here is basically showing the same thing in most areas, but as you see here, the different colors indicate different levels of drought, from just minor to severe. And you can see across much of the western U.S. The extreme and even exceptional drought in place. And then that actually arcs into the northern plains, which is another area in extreme drought conditions. And then even parts of the Midwest and portions of the East Coast have seen the development here of some drier conditions of late, but again, not to the extent of what's taking place out across the western U.S. Now, for this time of year, for late May and early June, this data set goes back 20 years, so basically since 2000. If you compare this year, just for this time of year, compared to those 20 years, this is the highest percent of the lower 48 that's under these drought conditions. So this is a pretty unique, we're in unique times here in terms of the past several decades and the regional extent of drought, or national extent of drought, which is really being driven by what's happening out across the western U.S. But this is a key driver of, again, our expectations of heat out west, especially up north. And ultimately, with these bubbles of heat, these EMLs, they're able to develop over what's already very dry areas. And then in turn, those bubbles of heat then start to move elsewhere. And we see that more focused across the northern U.S., which again, is already seeing dry conditions right now. Now, one area, if you go back a few weeks ago, one area that had been in significant drought, and for those in Texas, you are well aware of this. Even back a month ago, you had much of the state in that severe, extreme, and even a few pockets in exceptional drought. And that has changed markedly with the increase in rain activity in recent weeks. And what also looks to continue going forward is that the drought is certainly improving there. Again, not all of Texas, West Texas is still involved, but they are beginning to see some improvement here. But that's been where one of the biggest changes have been in recent weeks. Also up through Oklahoma and Colorado, previously in major drought conditions. But the spring in general has certainly helped to improve things. I want to now talk about one of our other key variables here that we put a lot of weight on in terms of our forecast, a bit more so weight in summer compared to winter. It's obviously a very important driver during winter as well, but there are different variables here, and one of the keys to winter, obviously, is kind of the state of the polar vortex. Going into a winter, is the polar vortex looking more unstable, or is it looking more stable? And then that can ultimately change throughout the season. When dealing with summer temperatures, though, obviously we're well away from the polar vortex. So that's not any kind of variable, but that's where sea surface temperatures become much more important. So what you're seeing here, this is a map of latest snapshot of water temperatures. Red shaded areas indicate warmer than normal readings. Again, this is a baseline of the past 10 years. So warmer than normal water temperatures in red, colder than normal water temperatures in blue. Kind of the first thing kind of that stands out overall is that, more areas of the globe being warmer than normal versus cooler than normal. But one area close to home, that a larger area of cooler than normal water temperatures, that's across the eastern Pacific. That's associated or been associated with the La Nina event, which is a period of cooler than normal water temperatures. This past winter was a moderately strong La Nina event, and as typically La Ninas go as you go through spring and then on into summer, that tends to back off or ease a little bit. But right now we are in these kind of neutral to weak La Nina conditions, these cooler than normal sea surface temperature areas there in the equatorial Pacific. Now, that's an important area, the equatorial Pacific, but what we think is more important that we put more focus on. Not everyone in the market focuses on this, but we do put more credence in what's called the Pacific Decadal Oscillation. I'm not going to get into all of the technical details there, but what the PDO is, currently it's in a negative phase. And what that does is basically looks at water temperatures across the central and northern areas of the Pacific. So we're in a negative PDO, and that signature clearly stands out on this map here. So when you're in a negative PDO, you tend to have this cold horseshoe of waters off the west coast of North America. You see that with the cooler waters there up towards Alaska, off the west coast, and then that kind of curves back into the equatorial Pacific. So that's our cold horseshoe. And then you have this warm tongue of waters extending from East Asia, Japan, and the Koreas and China, extending across the Pacific Ocean, almost into the Gulf of Alaska, basically. But that is a classic, what we call a negative PDO signature: cold horseshoe, warm tongue, and then the opposite of that is a positive PDO and the reversal of these water temperatures. But that's important in that for the summer, with this negative PDO in place, that especially for the western U.S., that's a drier signal, and then also that is a hotter signal, and so we're putting a lot of emphasis on that here for this summer. And then lastly, with what's going on across the Atlantic water temperatures, Gulf of Mexico, Caribbean, very important. In general, it's a warmer SST bias, but not as warm compared to a year ago, which is one of the reasons why we think this summer is going to be at least cooler relative to what occurred back last year. Now, one thing I do want to point out, and starting to get this question, and again, in the presentation, and I'd be happy to answer questions on this later, but do not go into any of the details about what happened in Texas here. But what's interestingly and why I'm including this chart is that there were some similar SST configurations going into last winter that also occurred back 10 years ago. Again, every winter is a little bit different, but the last time that we had a moderately strong La Nina event during the winter, that was back in the winter of 2010 and 11. Again, the last time we had this type of event. Still, La Nina is only one of other variables, and again, it took the polar vortex to become more disrupted, but just one thing that we're watching here going forward, and what this time series is looking at all of the La Ninas, or sea surface temperatures, that's what the vertical axis is, and everything below the center of the graph that's cooler than normal water temperature is basically a La Nina event, and then we chart through every month of the year how SSTs here played out. So you can see for this year, the dark black line in that moderate levels, but not some of the real strong ones. But we are expecting over time here, while SSTs this summer to be more neutral, we think with this negative PDO in place, with the moderate La Nina event of last year that actually does point in the direction of having a La Nina event for next winter. So yeah, it still is highly uncertain, but just kind of based on recent decades, and that at least is a signal pointing towards kind of what we call this double dip La Nina, where we have 2 consecutive winters in a row of La Nina. So that's something that we're going to be watching as we go through time, and we find very interesting. One last thing here in terms of the PDO, before we get into more of the tropical risks here, just a quick history of the PDO. So again, it is related to the whole El Nino La Nina oscillation, but it covers a much larger area across the Pacific. And as you see here on this time series that goes all the way back, there's data that goes back to early in the 1900s. If we just look at the more recent years here, we basically have gone back to more of this negative phase. That started last year in 2020, and then has, that was a big change from what we saw the second half of last decade. We're in this more of a positive phase. And then you have to go back to earlier last decade and back in portions of the 2000s where we had then more of a negative phase of the PDO. So doesn't tell us necessarily how long we're going to be in this negative phase of the PDO, but due to the fact that we're in this right now, it's at kind of moderately strong levels here. That at least points towards, it's something that doesn't change in like a matter of a few months. It's likely you go into these cycles here for at least several years. In some cases, as we saw back in the 50s and 60s, and early 70s, actually those could last for much longer periods of time. So, do want to wrap things up here with our thoughts of the upcoming tropical season. But before getting into the details on this, just a few quick stats about last year. Obviously, last year in so many ways was crazy, and on top of COVID, on top of politics and everything here in the U.S. last year. Then we had the 2020 hurricane season, which all of those red stats, and well, first off, what you see here, there's an animation of basically every storm last year, just like a basically satellite for a few hours of every storm going through the season. So, and then on the right, all of those stats, not going to go into all the details, but every red colored stat, those were records. So very impressive. And probably one of the most impressive, you see RI storms. RI stands for rapid intensification. That is a trend that we're seeing with storms, especially storms approaching coastal areas, that they're developing or strengthening much faster than they used to. That's still kind of new research, but certainly data is pointing towards these, an increase in these rapidly intensifying storms, which obviously become bigger disruptors as they move on shore. So, very impressive stat. One of the other items here, and one of the positive things, at least of last year, those stats at the bottom there, fatalities and damage, those two numbers were not records. So even for here in the U.S., so as extreme as conditions were, again, things could have been worse. And at least with, again, the prediction of the storms and just being prepared in advance, certainly, limited loss of life, and then obviously from a damage standpoint, at least help to limit things as well. For this year, we are expecting another active season, not to the magnitude of last year. But how we kind of quantify that risk of tropical activity, we use what's called the ACE metric, accumulated cyclone energy. We think it's a better metric for the Atlantic basin and for any tropical basin. We think it's a better metric of overall, basically a metric of risk and comparing this year to other years. So our forecast for this year is a range, or preliminary forecast, 125 to 150, again, which is above the normal of 110, not to the levels of last year, and but of all of the basins out there, Eastern Pacific, Western Pacific, Indian Ocean, it's the Atlantic Basin that, again, has the highest risk based on our research. The one thing, though, that is kind of stating the obvious going into really any season is that you have to watch these hot pockets, these smaller areas of warmer than normal sea surface temperatures. Those are, if you get a storm to track directly over those areas, then that's when conditions become more favorable for strengthening of the storms and ultimately, larger disruptive and more powerful systems. So that's something that needs to be watched here. And again, there are some around, but actually let me go back to the sea surface temperature one for a second. So might be a little bit hard to see for some, but right now, like the northern Gulf of Mexico has a bit of a cooler bias. Again, there are some warmer pockets in portions of the southern Gulf and in the Atlantic. And so, so it's really those, again, pockets there that, how are those change as we go through the season? Again, another important thing to monitor. So, again, with the increase in risk for the U.S., ultimately then, supply chain networks, whether that's energy, whether that's chemical, whether that's food and bev. This is a screenshot here from our NextGen application with some of our energy assets that we're monitoring. Primarily, this screenshot is more LNG and oil refineries, but again, compared to climatology, elevated risk, not to the levels of what we had a year ago, but again, for operations in the Gulf or East Coast, or even just being aware to some of the transportation hubs, whether it's cargo airports that could be used for, or ports being used for, your suppliers and that. Obviously at heightened risk, but at this time of year, there's just simply no skill. You can't talk about what portion of the coastline is going to be more favorable. You can start to go through periods throughout the season where you can start to narrow in, but at this stage of the season, you just can't get into that detail. But all in all, again, above average risk, another active season, just not to the levels of a year ago. So with that, I want to thank everybody here for their attention today, and again, thank you for the invite here, Mike and Asis, and happy to answer any questions that anybody has.
Do we have any questions? Okay, Mark, I think you covered it.
Wow, okay. Well, I'll be around here afterwards. I don't know if I just confused everybody or everyone's all... Oh, one thing that I will predict here, I forgot to mention before, my one final prediction is that everybody's going to have a great lunch here coming up and a great rest of the conference. So with high confidence, I'm giving that prediction.
Mark, thank you.